We're live. Okay, everybody, we are live. So let's talk about today's lesson. So we know that every triangle is equal to 1/2 the base times the height, right? But what if we don't know the height? If we don't know the height, we need a totally different formula. So in this case, we don't know the height at all, but we might know the adjacent side, and there's no hypotenuse. So these two are both called adjacent sides. Adjacent 1, adjacent 2 doesn't really matter, and we have an inclusive angle. So you need to know side, angle, side. So the formulas for every triangle is 1/2 the adjacent side times the other adjacent side times the sine of the angle, and that's it. It's super easy. So let me show you. So if you don't know the height, you don't need it. As long as you know side, you must know side, angle, side. Okay, so how does it work? Well, 1/2 the adjacent side, 10, times the other adjacent side, 9, times the sine of the angle, 40. Put it in your calculator, and you get, boom, 28. So I'm just going to go, well, I don't have a calculator. Well, yeah, I do. Here we go. So I'll show you. So it's basically just this, 0.5 times 10 times 9 times the sine of 40 degrees, and I get an answer of 28.9, and that's the area of this triangle without the height. It's kind of a cool formula, okay? All right, example 2, we kind of did the opposite. We know the area, but we want to find the angle. So I set up the same formula, okay? 1/2, 1/2 adjacent times adjacent sine of the angle, but in this case I know the area is 15. I know the two sides are 10 and 5. I'm looking at this triangle. Ignore the orange one. I'm looking at this triangle because there are two. Okay, I'm looking at this triangle right here in yellow. So it's the area, which is 15, is equal to 1/2 10 times 5 sine of the angle r. Okay, I want to find angle r. So I solved. I know that that's 50. Half 50 is 25. I solved. I divided by 25. Divided by 25. I get 0.6. If I want to find the angle, I must use the inverse button. So I went sine inverse 0.6. And I wound up getting about a 36.9 degree angle. So that's angle R, okay? But it says two possible, okay? Because it's possible to draw this exact triangle, but differently, okay? So I could have drawn it like this. Here's my 10, here's my 5, but a different angle R, and this could still have an area of 15. So we find, as you can see, that this angle now, R here, is supplementary, meaning between this angle and this angle is 180 degrees. I already know this angle here is equal to that angle, so to find it, I just go 180 degrees minus the value of R, which is 36.9, and I get another angle of 143.1. Okay? Example 3, find a regular pentagon inscribed in a circle with radius 6. Okay, radius 6, 6, 6. So what I did is I created 5 different triangles. Okay, and I looked at one of them and said, okay, well, let's find the area of this triangle. Well, I have 6 and 6, but I need this angle, but I do know within this circle is 360 degrees. Broke those 5 interior angles by 5, so 72 degrees is each interior angle. So, okay, here's my triangle. That's a 72, okay? So I went, okay, I used my formula, 1/2 adjacent side times adjacent side times the sine of the angle. I used my calculator, 1/2, 6 times sine of 72, and I got 17.1. And that's the value of one triangle. So I multiplied it times 1, 2, 3, 4, 5 triangles. Used my calculator, I got an answer of 85.6 for the entire pentagon. Okay? All right, turn the page. Now, example 4, you know, I have a triangle. So we drew a line straight down the middle to make 2 triangles, okay? And I have a formula for the area of a triangle. So I triangle 1, okay, is that triangle, and then I got triangle 2. So I got triangle 1 plus triangle 2. So triangle 1 is pretty easy because it's a right triangle, so I have a height. So I just use the old 1/2 base times height divided by 2, and that gives me 35. So the area of triangle 1 is 35. Circle that. I'm going to come back to it. Now triangle 2, I had to do a bunch of work. So the first thing I did is I found this diagonal, and I used Pythagorean's theorem, okay? When a squared plus b squared equals c squared, 10 squared plus 7 squared, and I ended up getting about a 12.2 for that side. I also needed to find that angle there, theta. Before I did that, I found this angle here, which turned out to be 55, and I used the tangent from this triangle. Tangent of 10 over 7. Tangent inverse gave me this angle to be 55 degrees. Now, if I want just theta, I subtracted 115 from this 55, and I got this angle at 60. Okay, that equals 60 degrees. So now I have my side angle side, and I can go then my 1/2, my adjacent side, 12.2, times my 13, my other adjacent side times the sine of the angle, 60, and I got about 68.7. Now, add the two triangles together to get the total area. Triangle 1 plus triangle 2, so triangle 1 was 35, triangle 2 was 68.7. I add the two together, the entire quadrilateral has an area of 103.7. And that's all I have for today. The homework is down there, okay? So come see me if you get confused.